Hey guys, so welcome back to the Neural Network Learns Arithmetic series, and in this part of the series we're actually going to be moving on past the operators and we're going to be creating the data for the actual arithmetic calculations themselves. So just to remind you, in the previous parts of this series we've actually been working on making the network recognize operators, so that would be like addition, subtraction, multiplication and division. Here's an example. So if we entered this kind of string 42 minus 42, just added a few leading zeros, then it's actually recognized this as a subtraction, which is correct, and these numbers, each of these four represent addition, subtraction, multiplication, division respectively, and it's on 0 to 1 based on how confident it is, and this was really confident on subtraction, which is true. So what this basically tells us is if we just focus on if we focus on the overall goal of this network, we want to basically enter a calculation like 1 plus 1, and we want the network to output the answer, like 2. And I know this is really redundant because computers can just, do this so easily, you just do that. But this is a good way of learning how neural networks work. And the way, if we whip out the preview like so, this was the plan we made on the introduction. It's a bit rough, but it does show the main idea. So we've got the neural network 1, which is the operators, and we've actually done this stage now. So now we're on to the second part, which is neural network 2. So I'll do the outline, and then we're also going to be creating the data in this part, and then next video we're going to be actually training a network on the data, and that should be the last part of that series, or we might do one more to actually test it. But yeah, so in this part we're just going to be creating data for the arithmetic. So we need to pass in the operator now that it's detected it, and we're also going to be using the operator. So if we pass this into this first neural network, it will tell us that it's an addition sum, so we can use that the fact that it's an addition sum to actually split this into its two numbers. Then we can normalize them, and then we can pass them into the network. So yeah, I'm just going to be showing you guys how this works, but first I'm going to need to clean up the code a little bit, because this is all to do with the operator stuff, and we don't actually want this right now. So let me just remove all of this, and I'm just going to rename this to operator.ts, because this is all operator related stuff, like so. And let's go to our script, and we don't want the operator anymore, so we'll just call this operator and we will comment this out. And we also want to make sure we save the operator network, so let's remember the config. So this is the network config, and we want to make sure we save the weights and biases which we trained last time. So I'm just going to go over here and so let's just create something like operator detection. We're going to move all of this into there, move that into there, and then we'll create a file for bias data. Basically this is just allowing us to store the data, because we're going to be overriding it in the next part. So we're going to need to store this data so that we can retrieve it later. And yeah, I'm going to have to think of a way to use these networks simultaneously, so we'll deal with that when we need to. So this is our weight data, and okay, so now we can actually get started. So I'm going to explain the idea first, like the overview of how we're going to train this network, and then I will actually put it into practice. And I should probably move this into operator detection as well, like so. Okay. So basically what we have is, let's focus on one example. So let's say we have a calculation 64 plus 17. So currently the network which you've created so far, it can detect this is an addition calculation, so it can detect that we want addition from this, which is how a child would also be taught. You're taught to recognize the operator and then you go from there. So it can detect that it's an addition operation. So let's just write neural network 1 detects addition. Then we can use this to first of all split this calculation into a I'm just going to use array, but this represents just data. So we're going to have an addition, the first number and the second number, like so. That's what it's going to do, and we can just write a simple function to do this. It can just be using this dot split operator, something like that. Then what we need to do is we need to make sure, because if you remember to our original data generation, the numbers are going from 0 to 999. So that means we could have a 3-digit number in here, or we could also have a 1-digit number in here, and we need to make sure we standardize this to make sure to actually account for this. So when we pass this into it, we're probably just going to add a few trailing zeros just to make sure that it fits nicely into the neural network. So, but we're going to make sure we remember this original number. Then what we're going to do is we're going to use another function to just standardize these numbers. So this is the data we'd have now. We just add leading zeros to each number until it's 3 digits long. And then what we're going to do is we're actually just going to move on to neural network 2. This is the role of neural network 2 from now on. So we're going to have to convert this data into binary, because as you know, neural networks like it when you give them ones and zeros as input, because it's to do with how you're going to be able to maximize the network's I don't really know the right word, but it's like the network's coverage, if that makes sense. So hopefully that makes, we should just convert this data into binary. So the first bit of data we have is the operator. So there's 4 operators. There's the addition, the subtraction, the multiplication, and the division. And if you know about binary, we know you can represent these 4 operators, 4 different bits of data with 2 bits. So we're going to have 2 bits. And we can even have a key, so we can have 0, 0 equals addition, 0, 1 equals subtraction, 1, 0 equals multiplication, and 1, 1 equals division. So we can represent the operator with 2 bits. Then we just have our numbers. So numbers can be a max of 3 digits long. And what that means is the maximum number we can have is 999. Okay? So to convert this into binary, what I did last time was just convert this as a string into binary, but that was actually really inefficient, and I think that's what led to us it being really slow to train, because we had to convert the entire string, and that would create a 6 or 8 digit binary, which is really unnecessary, because the maximum calculation this network is ever going to have to do is 999 times 999. Obviously, if you were training actual arithmetic, we'd use a bigger sample, but for now, this is the maximum we have, and the answer to this is actually going to be, well, I can just calculate it like so. So 998001. So that is a 6-digit denary number, which means we can actually represent this number using 20 bits of binary. 20 bits of binary. For output. So our output is going to be 20 neurons long for the 20 bits, and we're just going to be basically outputting in binary. This also means that our input numbers are going to be they're going to be 10 bits each, because you need at least 10 bits to represent a 9-digit number, because 2 to the 10 is 1024, so we're getting a bit of extra data space, but that's alright. So in total, what that gives us is our network configuration. We're going to have a network which has 2 plus 10 plus 10 for both numbers, so our network is going to have 22 bits of neurons in the input layer, and it's going to output, actually it's probably better, okay, let's have input 22 neurons, and the output is going to be 20 neurons. So hopefully that makes sense. Our network's not actually too big, although 22 and 20, that might be quite difficult to train, so I might consider switching to Node.js, but we'll see. For now we're just going to make the data, and then our hidden layer, I might have a, let's say we have a hidden layer of, I'm only going to have one, but we'll have a hidden layer of, we'll try with 10 first. We'll just try with 10 neurons. It's quite small, but hopefully it's enough because we already have a lot of neurons in the input and output layer. So here is our network configuration. Now we're going to have to start planning the data. So of course to train you need a lot of data, but luckily it's really easy to create data. So all we need is, for our input, we're going to need to generate a random operator. We need to generate a random num from 0 to 999 and another random number from 0 to 999, and there's our input, just like that. Of course we need to convert this into binary, convert to binary like shown above. But yeah, that's how we're going to do that. And as for the expected output, well, this is literally just going to be the result of this calculation. So it's going to be result of calculation. Again, this is going to be in 20-bit binary. So now that we've got that, we should be good. So I'm probably just going to make a time lapse of me doing this because the actual implementation is pretty simple. It's really just the idea. So I'm going to be generating this data now, as you can see. Okay, so I'm back. I believe I have actually now carried out the data generation as shown over here. So let's go to the code, and I've actually borrowed quite a lot from the previous operator generation, since we do still need to generate random operators, still need to generate random numbers, and yeah, I've generated 1 million random calculations again, although after experience last time we definitely won't be using all 1 million, so I think I'll be using a range tactic, but it's good to do it like this because we'll shuffle it anyway, and this just ensures we're covering all different types of, all different magnitudes of information. So yeah, here I'm actually going to show you guys what I mean. If we just console.log this, and we'll just get some random samples. So let's take this one. We have the addition operator. The first number is 2 and the second number is 901. So we have our 22-digit binary. Let me just make sure that's true. Yep. So this is a 22-digit binary input string, and we're just going to be showing. So the first two bits, I should say, represent the operator, and you can see I've actually just got an operator map here. So addition 0 0 0, subtraction 0 1, multiplication 1 0, and division 0 1 1. The important thing is that there's just a one-to-one mapping between each operator and corresponding binary. It doesn't have to be anything similar to what the operator was originally. It just needs to be a unique mapping. So the neural network which we're going to pass this into isn't really going to recognize the addition operator. It's really just going to recognize this 0 0 and map that to the addition function. But you know, we're still gonna, it's just important that it's unique. That's the only important thing, which is why it's also fine we can just convert these numbers into binary, because each number has a unique binary representation. So that's why it's important. So yeah, I'll show you guys over here. So 0 0, the first two bits represent the operator. You can see we've got this 1 0 to represent the multiplication, and let's see if I can find another addition. Yep, here another one. So we get 0 0 again. So now let me show you. So now the next 10 bits actually represent the first number, which is 2. So we have count, so we've got 5 up to here. Yeah, okay, so I'm going to type these numbers into the binary to decimal converter, and the way I converted them into binary was just using this function I found on Stack Overflow. Very useful. But yeah, so let's type these numbers in: 0 0 0 0 0 0 0 0 1 0, and that is 2. Okay, and then the final 10 bits represent the second number, which is meant to be 909. So let's see if that's that's also working. Like so, and oh, okay, yeah. So yeah, that does actually represent 909. So here we go. So we've got our input list. Now all we have to do is create our expected outputs, which is simply just going to be the actual result of this calculation. So I can just do this right here for you guys. Let's just work out the result. Actually, I will have to do it using each specific operator though, which might be a little time consuming. I could just do it right here though. So what I can do is I can do let result equals 0, and I can literally just do it here. So our two numbers are just a and b, but I will just use a and b like so. So in the addition bit we have result equals a plus b, in the subtraction bit we have result equals a minus b, multiplication a multiplied by b, and division is a divided by b, like so. And I've just realized that the division might cause some problems, especially if we're trying to divide by 0, so we might actually have to do some special cases for this. Okay, so let's do if b is equal to 0, then we will just set result equal to 0. I'm just gonna set I'm just gonna say x divided by 0 is 0. I know that's completely false, but that's just what we'll do for now, and we'll just call it a special case. And we'll also have to avoid floats because our results can't really handle that at the moment. It's only going to depend on integers, so I'll just round the answers like so. That shouldn't be a problem. We can still represent everything in 20-bit binary, so yeah, this should be fine. Our neural network might be a bit bad at calculating exact values for division because it's just going to round everything, but that's a trade-off we'll have to live with. Of course, if you wanted to make an actual neural network which did this, you could just start to account for floating point numbers by modifying your output layers a bit, but we won't do that for now, so we'll just round the numbers. So this seems fine. Another thing I would notice is we may have negative numbers, so we may actually have to account for that because a large proportion of our answers are going to be negative. So what we can actually do is I can just set it, especially for subtraction, I can just add one more. Let's go back here. So we can actually have 20 bits of binary, but we're actually going to have, let's say this is going to be represented 20 neurons, and we're also going to have to add one neuron for sign, which in total gives us 21 bits of binary for output. So the sign is either positive or negative, like so. So let's now change that to 21 bits, and then all we have to do is, this is still fine, we just have to create a new variable, let sign equals 0, and we can literally just do something like this. The only place where we're going to get negative numbers is in subtraction, so we can just do if result is less than 0, sign is equal to let's just set 1, 0 equals positive, and 1 equals negative, like so. So now set the sign equals to 1, and we will do result multiplied by 1, just so we can make all of the results positive. So there we go. Now we have our output format. We just need to put our numbers in. So have our result. Let's create a new list for outputs, and let's just start adding. So outputs dot concat, and I think I'm going to so we have our result in terms of a number. We're going to have to convert it into a string. Okay, yeah, because we're going to have to convert it into 20-bit binary. So convert result to 20-bit binary. Let's call this result string, and let's first convert this result binary string, and we'll use the function I've got from earlier, decimal to binary. That's going to give us the binary representation, but this may not be 20 bits, so we can do while result binary string dot length is less than 20. Let's just add some zeros in front of it. There we go. Okay, so now we have our result binary strings, 20-bit binary. We just need to split it up, so I'll use the same code from up here because it's the same sort of thing, like so. Actually, let's make the expected output clear. So we have 1 bit for sign bit, and then we have 20 bits for calculation. So our first part of the output has to be a result of has to be a sign. So we'll just have we can actually just add that in here, just put sign in there, and yeah, okay. Now we can just concatenate output equals outputs.concatenate result binary string, split it, and map the value to a number. Okay, so that should be our data generation complete. Now I can just show you guys a quick example. Let's console.log the let's console.log number 1, number 2. Let's console the operator, the result, and also the output. Okay, so I'll do the addition one first, and then we'll have to do we have a divide by 0 already, so I'll actually get a lot of them, but here's one already, and you can see it's just set everything to 0, so no mistakes there, which is great because otherwise it'd throw an error, and we do not want that. So you can see here we have num1 for 510, and the operator is plus, so the result is of course 514, and basically this first represents that it's a positive, which is good, and these 20 binary digits should actually represent the number, so let's just check that they do. 0 0 0 0 0 0 0 0 0 0 0 1 2 0 0 0 0 0 1 0, like so. And okay, yeah, so that's working. Now let's try and look for a negative subtraction. We should be getting one soon. Okay, sorry, I was looking at the wrong ones. Here we go. So we have our negative subtraction, and you can see the sign is of course changed to 1 now, and the result is still 402, but it's actually going to be negative 402. We've just changed it to 402 so that we don't have to deal with a negative result. But yeah, so you can see this is just going to represent 402. The one at the front actually represents the negative sign. Let's just ensure that that's true. So let's just put in this number, like so, and we do get 402. So it seems to be that our outputs are working well, and yeah, so we've got the correct inputs and we've got the correct outputs. Now we can just add this to our data and write this to the file. Four, 8, 12, 16, 20, 21. Okay, that's good. So there's our data complete. Hopefully it made sense what we're planning to do, and next video I'm just going to be training the network on this data. So thanks for watching, and I'll see you guys in a future tutorial.